As the dust and gas of a nondescript nebula in a nondescript region of space collapsed into a smaller and smaller area, it began to spin. The more material collected in the central region, the faster it spun. After millions and millions of years of gradual collapse, the embryonic clump of gas that would become our Sun was formed. The angular momentum of the ball of gas caused the remaining nearby material to flatten into a disk. Inside this disk, or protoplanetary ring, there were small deviations in mass. The points with the largest amounts of dust will clump together and gather more material due to their stronger gravitational pull. The smaller pieces will fall into the larger, colliding, vaporizing, and ultimately merging. After these chunks, or planetesimals, have gained enough mass to begin to clear their orbital paths, young forms of planets will begin to take shape. The early life of a planet is characterized by raining fire, molten temperatures, and near constant bombardment. This will fragment the bodies into innumerable pieces, some of which will be recaptured and reclaimed by their parent, others never to return. Each white line marks the orbit of the pieces left over from the birth of our solar system, called asteroids. These ejected chunks are valuable specimens to examine and deduce the specifics of the solar system's violent and chaotic birth, such as the asteroid Psyche. Psyche is unlike most other asteroids we have found. It is classified as an M-type mesosiderite asteroid. M-type asteroids boast a relatively high albedo and are typically made from a combination of iron and nickel and are the third most common type. Albedo is a measure of how much solar radiation gets reflected off of any given surface. A hypothetical object with an albedo of 0 will reflect no light at all, and an object with an albedo of 1 will reflect 100% of any radiation that hits it. Although M-types are common, only 0.7 of all meteorites collected from Earth's surface are classified as mesosiderites, which makes them rarer than pure metal meteorites. This body is very intriguing, as Earth's roiling metallic core is made of these same metals. Due to its makeup, astronomers believe that Psyche could be a protoplanet's ejected core and could lead to valuable insight on our own planet's inaccessible interior. Radar observations of Psyche have confirmed a few key facts about the metal world. It is ellipsoidal and is often described as potato-shaped. It has a few major craters, the biggest of which are named Mero and Panthea, after the twin riches of the Roman story Metamorphosis, where Psyche itself gets its name from. In 2022, NASA's Psyche mission is set to launch. An orbiter will be sent to the asteroid in order to verify its hypothesized metallic makeup, examine its gravitational field, map its surface, and probe its possible magnetic field. In 2023, after a year of floating gently through interplanetary space, the Psyche orbiter will dip into Mars's potential gravitational well and take some of its momentum for itself in a maneuver called a gravity assist to help it reach the asteroid between the orbits of Mars and Jupiter. After its angle and momentum are changed, the orbiter will drift for 3 more years until it reaches its destination. Arriving in 2026, it will orbit the asteroid many times, surveying its properties, investigating its fields, and allowing us insight on the formation of Earth and other planets.